So on this one, we're going to title our notes Exponential Equations. And in the past, we've used no calculator, to solve a problem like this. 2 to the x power equals 8, right? Which, in that case, what is 8? Guys, we've done mental math to get what?
2 cubed.
Right, x is 3. So the exponent is 3. Now, we're going to move on, though, because in real life, every single exponent isn't perfect, okay? So what we're going to do is we're going to start learning how to do problems that you can't use mental math to do, right? We're going to make them a little harder. So we're going to make our calculators do the math for us, right? So, for example, if I gave you the problem 2x equals 9, okay? If you have 2x equals 9, can you do that problem in your head? No, you can't rewrite 9. It doesn't work. Okay? You can't change the base of 9. There's nothing you can do. Okay, you could do 3 squared, but then you wouldn't have a common base. So, but though, mentally, if I was going to kind of estimate the answer, okay, I know in my head that 2 squared, okay, is 4, 2 cubed is 8, okay, and 2 to the 4th power is what?
16.
So if I'm looking for 2 to what power is 9, if 2 cubed gives me 8 and 2 to the 4th gives me 16, I know my answer is really close to 3, right? Because I just need 9. 2 cubed is 8, and all I need is a little bit more. I just need 9. So it's going to be 3 point something. Now, like we talked about, another thing in the past is that if I had asked you to take 15 divided by 3, yeah, you can do that in your head. It's very easy. Okay? If I had asked you to take 15 divided by 3.2, it might take a little more work, but that's dividing with 1 decimal place. It's not too bad. Okay? Which is kind of, those are the 2 types of problems that we've been solving. We're going to move, though, to problems like this where you have something like 3.12784. I would never ask you to solve that in your head, okay, or mathematically calculate it, right? So that's a lot like this problem here. We could do trial and error all we want. We could try 3.1, 3.01, 3.11. Okay, and a long time ago, before there were calculators to do the algorithm for a log, okay, that's what people did. Okay? But now, the calculator can come up with a log for you. They can come up, when I'm saying come up with a log, what am I meaning? You can come up with the exponent. The calculator will find the exponent for you, right? And in the same kind of aspect, if I told you to take x plus 3 equals 5, how would you solve for x here? You would subtract 3 from what?
Both sides.
From both sides. Subtracted 3 here to cancel it, and subtract 3 on this side to keep it even. Okay, we've done that so many times that you just understand it perfectly and quickly. Now, in this problem, when you're trying to solve for an exponent that doesn't, in your head, come up really quickly, okay, that you can't just mentally solve, then what you do, kind of like here in this problem, we just subtracted 3 from both sides. On this problem, we log both sides. And it's fine, as long as you do the same thing to both sides, it's legal, correct? It's an equal sign. So if I write log 2 to the x power equals log 9. That's how you solve the problem. Okay, because then we're going to use the property of logs. What happens to an exponent? Where does it go? Where do we change an exponent to? It goes in the front, right? It becomes the numerator. So this brings out to the front. So now you've got x log 2 equals log 9. And from this point, you're trying to solve for your x, okay, this value here. So you want it all alone. So what do we want to get rid of? The log 2. How do you get rid of multiplication? You divide. So you divide by log 2. On this side, it goes away. divide by log 2 on this side. So x finally equals. Now let me explain something. Just like right here, I would never want to do this problem in my head. Okay? You would use a calculator. Same with this. Type it in your calculator. The log button is next to the 7 on your calculator, on most of them. So you're going to type in log 9, close the parenthesis, divided by log 2, and your calculator will compute the exponent we're looking for. We know the answer is a tiny bit over 3, right? Because 2 cubed gets me 8. I'm trying to get to just 9, just a tiny bit over 3. So what was the answer you got? Approximately 1.7. Right, and you can even check and make sure, 2 cubed is 8, so 2 to the 2 to the 3.17 would be about 9. Okay? So that's the idea of today. The idea is that, okay, listen one more time. In a problem like this that we solved a million times, to solve for x, you and I both know, just subtract 3 from both sides. Okay? In a problem like this, when you're trying to solve for x, if x is an exponent, you log both sides. And your calculator will compute the log for you. Okay? So let's try another one. So the directions are just going to be to solve. So for number 1, you have 5 to the x power equals 12. Once again, you're solving for an exponent. So to solve for that exponent, okay, what can I do to both sides that is going to force that x down onto the base instead of up as an exponent? What can I do to both sides? You can actually what? Log both sides. So you're going to log this side and then write log on the other side. And then the property of logs now says that this x belongs where? If it's an exponent, to expand it, you can put it in front. So x log 5 equals log 12. So to solve for x, we're going to divide both sides by log 5. And x equals 1.54. And you can go back and check. 5 to the first power, right? Think about this for a second. 5 to the first power is 5. And 5 squared is 25. Well, I'm looking for 12. It's in between those, so 1.5. Number 2. 6 to the negative x equals 10. What are you going to do? If you have a negative x or anything, if you're trying to solve for an exponent, what allows you to solve for an exponent? Log both sides. We're back to the same problem up here. What allows you to solve for x up here? Subtract 3 from both sides, right? We're just used to seeing that, okay? But when you have a problem like this, if you're trying to solve for an x and you don't know, I don't know what the log is. I can't get from 6 to 10, right? So if you actually write log 6 to the negative x on one side and log the other side, okay, then you can apply the properties of logs. The negative x is pushed in the front. So you have negative x log 6 equals log 10. To solve for negative x, you want to get negative x by itself, so you have to get rid of this log 6. So you're going to divide both sides by log 6. Try it on your calculator and be sure you can actually get your calculator to do the math for you. So log 10 divided by log 6 is 1.29. So x is negative 1.29. And once again, you can go back and check. I'm saying x is negative. Well, the original problem says you want the opposite of x, so it's going to put positive here. So 6 to the first power is 6. So 6 to the 1.2 would be a little more. Number 3. 17 to the 3x power equals 150. Okay, to push the 3x down, we're gonna log both sides. So log 17 of 3x equals log of 150. The property says that that's gonna push the 3x in front. So you get 3x log 17 equals log 150. To get 3x all alone, you're gonna divide by log of 17. So 3x equals log 150 divided by log 17 is 1.768. And divide that by 3, and x is 0.59. And you can check your answer. Go back and check. Take 17 and raise it to the 3 times 0.59 and see how close to 150 you get. It would be horrible to try to do that by trial and error, though. It would just take forever. Okay, number 4. Alright, on number 4, be careful about the way you read this. So watch as I write it down or it will be confusing. I want 3 to the 4x power. Okay, and I'm going to divide the whole thing by 7. So it's not 3/7 to the 4x power. It's just 3 to the 4x power divided by 7 equals 5. Okay, and then knowing that, what's my first step? What should I do? Multiply by? You're going to multiply this by 7 and this side by 7. So now you're at 3 to the 4x power equals 35. And again, you're going to solve for an exponent. How are you going to push the exponent down? What do you have to do to both sides? You have to log them. So I want the log of 3 to the 4x to equal the log of 35. That's going to push the 4x in front. Divide both sides by log of 3, and 4x should be 3.2362 approximately. Then you have to divide it by what? What's the last step? Divide it by
4.
So x is 0.81. At the end, like I would leave the answer, when I do log 35, she's asking what I round to. So I would take log 35 divided by log 3. I would leave that answer in my calculator, okay, and then divide by 4. So I'd round to there's hundredths at the very end. Wait, right? Wait till the end round. If you round and round and round over and over, it changes your answer sign. Okay. Go to the next one. So the same with this one, 8 to the 2x minus 3 all over 5 equals 6. What do you think you're going to do first? Right. I'll give you a second to try it. Right, so the first step on this problem will be to multiply both sides by 5. So now you're at 8 and 2x minus 3 equals 30. To move the exponent down, you log both sides, and it's going to push this in front. So you have 2x minus 3, right? Log of 8 equals log of 30. Now to solve, you're going to divide both sides by log 8. And you have 2x minus 3 equals 1.64. So when you add 3 and divide by 2, you get 2.32. The next one, number 6. 4 to 5 minus x power equals 19. It's exponential, right? And like I've said already, if you're trying to solve for an x, and x happens to be the exponent, okay, the thing you're supposed to do to both sides is log them. So if you logged both sides, then you can use the property of logs to solve, because this is gonna be pushed in front. So you now have 5 minus x, log 4 equals log 19. Divide both sides by log 4. So 5 minus x now equals approximately 2.12. You're gonna subtract 5 and change the sign, so you get 2.88. And you can check it for reasonability. Plug it back in. All you have to do in your calculator is 4 raise to the power of 5 minus 2.88. Make sure you get almost 19. Okay, now, we're gonna switch it up a little bit, okay? The directions now are gonna say to find each log. Okay, find each logarithm. So for number 1, if I told you log base 3 of 11. Now these problems with no calculator, right, we would have to rewrite with a common base and then the exponents are equal. But can you rewrite 11? No. Can you mathematically easily get from 3 to 11? No. I'm looking for the log, I'm looking for the exponent. What exponent gets me from 3 to 11? I don't know. 3 squared is 9 and 3 cubed is 27. So I know the answer is close to 2, right, because 3 squared is 9. So it's a little bit over 2. So you're actually gonna now work it the same way you've done all the others, right? You're gonna set it equal to x, okay? Set equal to x and say, well then 3x is 11, right? And how are you gonna solve that? Log both sides, right? You're trying to find an exponent, now it's the same problem. You should know how to get from here to here. So if you take log 3x equals log 11, pushes the x in front. So log 11 divided by log 3 is 2.18, which is what we said. I know 3 squared is 9. I was only trying to get to 11. Okay? Here's another one. Log base 7/8. Got a fraction. We haven't had that really. To the 3/4. Okay, so I don't know. I don't know what exponent, I don't know the log. I don't know the exponent from 7/8 to 3/4. So set it equal to x and circle now. So 7/8 to some power equals 3/4. If you're solving for x and you can't do mental math and you can't rewrite, then log both sides. And use your calculator. So this becomes x log 7/8 equals log 3/4. Divide both sides by log 7/8. So now x equals 2.15. Okay, so every single problem that we've solved so far had an exponent in had an exponent that was x, right? Go back and look. The exponent was x, the exponent was x. Here, 3x, 4x. All the exponents had x in them, okay? Well, what is the reciprocal, or the inverse, I'm sorry, of a log? It's exponential, right? So now, we've already studied this whole section we're about to do now, but I'm just showing you that you can go either way with it. So this section, the directions are solve. And we've actually even had a test over this part, so it shouldn't be too easy, too hard, sorry. Number 1, x to the 2/3 power equals 26. What's different about number 1 than every problem we've done so far?
The x isn't in the.
Yeah, the x is the base. The x is no longer an exponent. It's not a log. Okay? I'm not looking for the exponent. I know the exponent. It's 2/3. I'm looking for the base. So a log isn't going to help me out here. So how do I get x by itself? When x is an exponent, I log both sides to get x by itself. What am I going to do to get here? I have x to the 2/3. I don't want x to the 2/3. I want x. How do I get rid of the 2/3? What do I do to it? What would I raise the power to? We've studied it before. Two wouldn't be enough. 3 halves. You flip it. Right. So you're going to take this side. Watch. You'll see what I'm talking about. And you're going to raise the power of 3 halves because this is the reason. 2/3 times 3 halves. Okay, if you multiply straight across, you get 6/6, which is what? 1. Or you'll notice they all cancel. So by raising it to the power of the reciprocal, okay, it cancels, and you get just x, or x to the first power. But whatever you do to one side, you have to do the other. So you're now going to raise this to the 3 halves as well. Now, when we didn't have a calculator, we would do this in our head by taking the square root first. Can you take the square root of 26 though? No, so use your calculator. Type in 26, okay, raise the power of 3 divided by 2. Which will give you the answer. Number 2. 5y plus 2 to the 5th equals 42. Five y plus 2 to the 5th power equals 42. Okay, how do you get rid of the 5? Well, not multiply necessarily, but raise the power of 1/5. Isn't that going to get rid of a 5? What's going to make 5 1? By multiplying it by 1/5, right? So you have to raise the power of the whole thing by 1/5, because 5/1 times 1/5 is 1. That's the reason. So that would cancel and drop down your 5y plus 2 on the left side, which now you have to do it to the same over here. So in the calculator, find 42 to the 1/5 power. Which is what? 2.11. So subtract 2 and divide by 5. And y gives you 0.022. Try this one. We have 2 more, 3 and 4, and we're done. There's 2 different ways to do this problem, so if you're asking somebody else, there's more than one way. Okay, so to me the easiest way is to recognize that this is the same thing as x power over root. That to me is the easiest. Okay, if you don't recognize that though, okay, the other way to do it, let's say I didn't recognize that, I can raise it to the what? Yeah, you can raise it to the 4th power on both sides, which then gives me x to the 5th equals 70 to the 4th power. Which is huge. Okay, it gives you a huge number. But then you've got to raise that answer to the 1/5 power. So that's one way. This way is a lot easier. Oh, I see. The root drops, thank you. Guys, this drops. When you take the fourth root, the radical drops. So it would go from here to here. The easier way, though, is to recognize this is the same as this, and to get rid of it just by taking 4/5. So that x is 29.93. Okay, last problem. The fourth root of 3x minus 2 equals 2.81. What's my first step? How do you get rid of the fourth root? Raise it to the 1/4. Raise it to the 1/4, right? How do you get rid of a square root? Raise the 1/2. So, raise it to the 1/4.
You raise it to the fourth.
I'm sorry, yes, that was an accident. I didn't mean to confuse you.
Nobody's.
I was not even paying attention. To get rid of the fourth root, raise it to the 4th. Thank you. Gosh, my brain's dead. Thank you. So now I'm at 3x minus 2 equals 2.81 to the 4th power is 62.35.
Add 2.
And divide by 3. Add 2 and divide by 3 to get 21.45.
It really was